Imagine a world where the horizon is not a curve, but a definitive, terrifying end to all things known. For most of human history, our ancestors looked at the flat expanse of the ocean and saw a literal boundary. Today, we view the spherical Earth as an absolute truth, yet a persistent curiosity remains about the alternative. What if the planet we call home wasn't a marble, but a vast, shimmering disk drifting through the void? This thought experiment isn't just a flight of fancy. It allows us to explore the fundamental laws of our universe. To understand why the Earth is round, we must first imagine the chaotic physics of a world that is flat. On a flat Earth, the most basic force we take for granted, gravity, would become our most surreal and constant enemy. In a sphere, mass is distributed equally, pulling everything toward a central core with a predictable downward consistency. But on a cosmic disk, the center of mass sits right in the middle of the circle, near the North Pole. As you move toward the edges, gravity wouldn't pull you down, it would begin to pull you sideways. Walking toward the ice wall would feel like climbing an increasingly steep and invisible mountain of gravitational force. Every step away from the center would require more energy as the Earth tried to drag you back. In this world, the Great Wall of Antarctica isn't a barrier of ice, but a vertical cliff of warped physics. This sideways pull would wreak havoc on the very architecture of nature, starting with the silhouettes of our forests. Trees would no longer reach straight for the heavens. They would grow at sharp, diagonal angles to resist the tug. To an observer at the edge, a forest would look like a line of desperate sprinters frozen in mid-collapse. Even the simple act of a rainstorm would become a centralized catastrophe of massive global proportions. Instead of falling straight to the soil, raindrops would be pulled horizontally toward the Arctic center of the disk. All the world's water, our vast oceans and gentle rivers would eventually migrate toward that single central point. We would be left with one gargantuan, bulging ocean in the middle, surrounded by thousands of miles of desert. Beyond the liquid chaos, the very air we breathe would become a weapon of atmospheric pressure. Gravity doesn't just pull on rocks and water, it anchors the invisible blanket of gases that keeps us alive. On a disk, the atmosphere would be thickest at the center, creating a crushing weight on anyone living there. Meanwhile, toward the edges, the air would become dangerously thin, leaving inhabitants gasping for oxygen in a void. But the real catastrophe isn't just the distribution of air, it is the absence of a magnetic shield. Our round Earth has a spinning liquid metal core that generates a massive geomagnetic field around the planet. A flat Earth, static and thin, would likely lack this churning dynamo, leaving us defenseless against the heavens. Without this shield, the solar wind would strip away our atmosphere, blowing our air into the cold cosmic dark. We would be exposed to the full, unfiltered radiation of the sun, damaging our DNA and scorching the land. Life, as we know it, would be forced to retreat into deep bunkers or face a slow, silent extinction. Then there is the question of time. How would such a world experience the transition from day to night? Flat Earth models often suggest a sun that acts like a celestial spotlight circling above the disk's surface. However, physics dictates that a spotlight sun would be visible from every corner of the Earth at all times. To create a true night, the sun would have to physically dip below the edge of the disk and disappear. This would mean the entire world would experience sunset at the exact same moment, destroying the concept of time zones. London, Tokyo, and New York would all fall into darkness simultaneously, governed by a single, global clock. Furthermore, for a sun to orbit a flat Earth, it would need to be much smaller and closer than it is. If the sun were its actual size, its massive gravitational pull would simply swallow our disc-shaped planet whole. If it were tiny, it wouldn't have enough nuclear fuel to keep us warm, turning Earth into a frozen wasteland. We find ourselves in a Goldilocks paradox, where a flat world simply cannot sustain the warmth of life. Even if we solve the sun's position, we encounter a visual impossibility: the way we see the world. On a flat plane, a telescope would theoretically allow you to see the Eiffel Tower from a balcony in New York. There would be no curvature to hide distant landmarks, only the hazy interference of the atmosphere itself. Yet, ships consistently disappear hull first over the horizon, a phenomenon observed by sailors for thousands of years. To explain this, we must look at the stars, which behave differently depending on where you stand on a sphere. In the northern hemisphere, we see the Big Dipper. In the south, the Southern Cross, dominates the sky. On a flat disk, everyone would see the exact same constellations, merely at different angles of rotation. Then there is the matter of our digital world, which relies entirely on the geometry of a globe. Every GPS coordinate and satellite transmission is calculated based on the Earth's precise spherical curvature. For GPS to work on a flat Earth, thousands of satellites would need to hover in impossible, static positions. The energy required to keep them from falling into the disk would be greater than all power plants combined. If the Earth were flat, the very concept of a flight path from Australia to South America would change. Planes would have to fly over the North Pole to reach their destination, doubling their travel time and fuel. Instead, they fly across the Southern Oceans, a route that only makes sense on a three-dimensional globe. This brings us to the most mysterious part of the Flat Earth legend: the Great Ice Wall. Proponents claim Antarctica is not a continent, but a 150-foot-tall ring of ice encircling the entire world. They suggest that NASA guards this boundary to prevent curious explorers from falling off the edge. But thousands of independent researchers and tourists visit Antarctica every year, documenting a very different reality. They find a continent with a center, a South Pole, where all longitudes meet at a single point. If the ice wall were a ring, the geography of the southern hemisphere would be stretched beyond recognition. If a flat Earth is physically impossible, why does the idea continue to capture the human imagination? Our brains are not designed to perceive the curvature of a planet nearly 13,000 kilometers wide. To our eyes, the ground looks flat, the water stays level, and the world feels small and manageable. This is the result of a cognitive bias where we trust our immediate senses over complex, abstract data. Belief in a flat Earth often stems from a deep underlying distrust of large institutions and established authority. It is a symptom of a world where information is plentiful, but the truth feels increasingly out of reach. When we reject the globe, we aren't just rejecting science, we are trying to reclaim a sense of certainty. However, the reality of a spherical Earth is far more beautiful and intricate than any flat model. A sphere allows for the elegant dance of the seasons, driven by the tilt of our axis as we orbit. It creates a world where every point on the surface is equal, balanced perfectly by the pull of gravity. Our roundness is what gives us our protective atmosphere, our magnetic shield, and our stable, predictable climate. It is the geometry that allows life to thrive in every corner, from the tropics to the frozen poles. Science isn't a collection of cold facts meant to kill our wonder, it is the tool we use to see clearly. By understanding the laws of physics, we realize that we aren't living on a simple, flat stage. We are passengers on a magnificent, self-sustaining spaceship, hurtling through the infinite dark at incredible speeds. The mystery of the Earth's shape was solved long ago. But the mystery of our place in the universe remains. Perhaps we cling to these legends because they make the universe feel a little less vast and intimidating. But there is a profound sense of awe in knowing that we live on a fragile, blue marble. So, if you could stand at the edge of the world, what would you hope to find there? In the end, the most important boundary isn't a wall of ice, but the limit of our own curiosity.